Hi, everyone. Happy Wednesday. It's Alan Schimmel for TechStrong Gang. Welcome to join us right here on Hump Day. Kind of hard to believe Wednesday. I blinked. It was Monday. We've got a great show today. We got some interesting things going on. Not all AI, but some AI. We've got some really interesting people to talk about them with. They're all regulars here on the gang. Let me quickly introduce you to them. We have Mitch Ashley, Chris Blask, Kate Scarcella, Dan O'Brien, and of course the Dean Mike Fazard coming at you from Lake Placid. I don't know if he's going off the ski jump like Eddie the Eagle or what, but whatever. Welcome, gang members. Thanks for being here. You know, we're going to start off today. We're going to come back to the vibe, but we're going to start off with ARM. Mike, you know, to me, ARM is one of the untold great success stories in tech over the last 10 years. Why don't you start us off there?
Yeah, their CEO came out and just kind of made a comment to the fact that they now have 70,000 customers for our ARM chips. And we all talk about GPUs all day long, but most of the workloads I know are running on traditional CPUs still. And we talk about Intel and AMD, but looks to me, I think it was last year when AWS told me, I think half of their new workloads are running on their ARM-based chips. So Dan, is ARM kind of like rapidly emerging as, I don't know, the number 2, 3 player in chips, or why don't we talk more about ARM?
Yeah, listen, I think the ARM story has been incredible. You know, if I had to pinpoint why we don't talk about ARM, it's because generally I think we're talking about their customers. I mean, they are really the key enabler of a lot of silicon innovation in the industry over the past decade or so. It comes from really more of an embedded background, really the primary player in mobile, enabled by their customers like Apple, Qualcomm, MediaTek, Samsung, Huawei. But more recently, really making a significant move in the data center space. And that's really where the action is, as we know. AI silicon is all the rage. And, pretty much every competitor that we talk about to NVIDIA is really being enabled by ARM. I mean, Intel and AMD would be kind of the exceptions there. And I think we all know kind of Intel's woes. AMD getting more competitive. I think their rack scale solution coming next year will, continue to give them some momentum on the GPU side. But really, all of these AI ASICs are really driven by ARM. When we think about, Google's TPU, ARM IP, with some Broadcom design help behind it. Everything Marvell is doing. Really everything the hyperscalers are doing through vertical integration enabled by ARM. You see, Graviton and, Inferentia and Trainium at AWS. You see the Maya silicon that Microsoft's working on. Really ARM is the enabler of that alternative to NVIDIA ecosystem. And, a lot of it coming from really their history as somebody who's been able to really drive a lot of performance at a lot lower power, envelope. Obviously, power consumption is becoming a really key bottleneck in AI. But, they've also invested a lot on the software side. I think we continue to see that, software is the great enabler of hardware. In order for a new chip architecture to latch, you really need to invest heavily on the software side. And I think ARM's done that. So definitely a hot name, somebody we should probably be talking more about. And again, to the degree we talk about them less, it's because they really give a lot of the shine to their customers.
It's almost not as much customers as truly channel partners, right? Because I think that's the key to ARM, their distribution. How many times have we sat on here and said, who's going to compete with NVIDIA? My God, this is a runaway train. No one can compete with NVIDIA. And I'm not saying anyone can at a $4 trillion valuation. But when you look at ARM's distribution, and that's, Dan, to your point, you just nailed it. We don't hear about ARM. It's because most of their channel partners, their go-to-market partners, are companies we're hearing about. Now, adding them all up, I still don't know if they come close to NVIDIA's, market share or penetration there. But remember, NVIDIA is pretty much, it was a gaming chip now, of course, but the real bread and butter here is the AI chip. I think ARM has a much broader footprint of technology, in terms of chips, it's not, you mentioned it's the mobile chip. It's now the data center chip. It's the laptop chip, right? It's an enviable
Yeah,
powerhouse.
significant inroads with PCs, right, enabled by Apple and Qualcomm, where they've taken
Sure.
some share. Uh, and starting to get into the market themselves. I think we see, ARM launching its own chip sometime later this year. It's been widely reported Meta is a kind of key customer for them on that side. But really much more playing on the CPU side, than the GPU side at this point in time in the data center. But, companies come out and said targeting 50% share of data center by the end of this year. So, clearly making some significant inroads. And I think a lot of that has been enabled by the, internal silicon efforts of the hyperscalers. The past several years, I think notably Google and AWS quite far ahead on that front in terms of using ARM.
Yeah, ARM's kind of one of those 20-year overnight successes, right? They've been at this for a long time. But to your point, Dan, we talk about them when we talk about Qualcomm and Apple M chips and all of the different the licensing that they've done with their architecture, which has been frankly a brilliant strategy. It's the alternative to Intel, where here's the architecture, you can build your own chips using that, licensing that technology. And you mentioned this too, and I want to emphasize it because I noticed about 3-4 years ago when you were talking to ARM people, they were emphasizing how do we get compatibility for ARM into open source projects? How do we get compatibility for ARM into data centers? How do we get compatibility? So they've made a real effort to kind of go at the low end of let's get into the infrastructure, let's get into the software stack to make sure we're already there so people can compile and run on ARM just as well as they can, in Intel or in some cases NVIDIA.
So, Mitch, we've talked about the concept of application modernization on this show, and it's always usually in the context of mainframes to something that's x86. And as I scratch my head and I think about all this, I'm like, am I going to see app modernization where we're going to take legacy workloads and move them from x86 to ARM because there are benefits to be had? And how hard or how big a lift might that be?
Absolutely. And that goes to the whole, underlying software substrate. If your open source stack that you're using, all the different element of projects, for example, or support ARM already, you can recompile your applications. Maybe you do some design to optimize for mobile kind of apps if that's what you're doing. But it's a much smaller lift to do that today. By the way, we talk about modernization of mainframe applications. Well, how old is Netflix's infrastructure, right? That's been built over many, many years. There's a lot of legacy stuff they have. We think of Netflix and AWS and Lyft and different companies that we work with today as new and innovative, but they've had software stacks that have been present and built up over many years. So everybody has got this modernization challenge to some degree where they need to keep up their software infrastructure and their stack moving forward.
Well, and this is all happening in a macro environment where, to be clear, none of us have any idea where the hell AI is going, right? And suddenly, in the last couple of years, we've all gone, oh, graphics processors are really good at vector math, which is what we need to run the LLM holographic spaces and so forth. And it goes through the roof. At the same time, the use of those chipsets and that technology and that whole stack is using more power than, God's own little bunny is to make popcorn, right? And it's becoming more evident that there's other ways to do it. There's tasks that inference engines are fantastic for, but asking them to add 42 plus 3 is not really one of them. And so at the chip level, everyone is focusing on GPUs. But at the architecture level, and I have no idea whether this is part of it, but this is the way I think about it, we've all forgotten other chips exist. Other processors do things. Way better things quite often, as long as you're not trying to, fold a molecule.
And with a lower energy consumption, which is as we go forward. As a person who has dealt extensively with energy, I can tell you that I have seen them, the ARM architecture through IoT devices and IIoT devices, and that footprint is massive. So I think ARM for the win.
Well, the trend in the market's towards heterogeneous compute, right? Really design silicon for the specific workloads. That's been kind of the mega trend over the last several years, that more workloads that are finding the way to silicon that's kind of purpose built. And ARM's really been the great enabler of that, right? So I think, that trend continues. And, to Chris's point, on a lot of the stuff we're playing with in AI, we may have a fundamentally wrong architecture for where it's going to land in the long term. And, ARM seems really well positioned to benefit from some of that rationalization and that balancing of, kind of price performance that needs to happen across the market.
They've got the licensing model down for sure, Dan.
Well, and Dan, I love where that goes as well, because that takes it sort of a step further than what I was thinking. But yeah, I'll say it. We think that 90 to 99% power reduction to achieve the same task can be done, right? It's just, as you look case by case, it's sort of ridiculous. But as you take a step further, because of the adaptability that we have these days with these sort of tools and structures, not just GPUs or x86 or, why not, remember EEPROMs and programmable chips and so forth? It was really big back in the day, and customized hardware for workloads. Yeah, I think you're exactly right. So if they're down that track, I'm with them.
Let me come back to the best kept secret in tech kind of theme on ARM here. If we weren't in this NVIDIA irrational exuberance, if I may call it that at some level, what a story ARM would be, because they would be competing with just AMD and Intel. And quite frankly, they're kicking butt. Well, AMD's a channel partner, right? At some level, but they'd be kicking butt. I mean, when you look at what Apple has done with their chips, with the Apple Silicon, compared to the Intel, based on this architecture, it really is. I mean, it's a phenomenal, phenomenal story. And they've been able to do it. Now, Dan, I know you used to cover ARM back in the day. I'm not going to say you're
when
old.
They were a public company before SoftBank bought them. Covered them as an equity. Yeah, and they're riding the NVIDIA train too, right? They're on the CPU side, and their CPUs are right alongside NVIDIA's GPUs. I mean, let's not forget NVIDIA did try to buy ARM, which maybe was the validation we all should have picked up on at the time as to their potential. Obviously, that didn't get through, antitrust, but NVIDIA's Grace CPUs are all based on ARM architecture as well. So certainly they would be picking up more if NVIDIA weren't doing what they were doing, but they're benefiting from that trend as well.
Yeah, their Tegra chip is based on ARM. Several things.
Anybody besides me kind of have a perception that maybe these ARM chips are just fundamentally more secure than x86 chips? Is that a benefit of this as well?
I don't know. I was thinking, I met a person who was 5, 6, 7 years ago, and he just left Intel as their, not the firmware, but the actual chip security person. He just got to the point he had to say, we can't tell anymore. Right. So maybe, security at the chip level can be, optimized. But again, we're levels of complexity. And I'm thinking out loud here, recursing these same tools back on them, maybe we can raise chip level security. But frankly, I never count on that sort of thing. It's beyond the ken. You need to secure everything at a layer you can see.
And the other thing, Mike, that sounds very much like the old, Apple's much more secure than Windows kind of argument, right? Look, when you have a certain amount of market share, you get that bullseye, right? And this might be an interesting thing to see how it plays out. ARM keeps making a lot of noise about how much market share they're getting. They become more of a target for the security people. I don't believe that any of these architectures are necessarily inherently more secure than others, right?
I think that's fair, Alec. But I also think, we can probably chart ARM's rise, alongside kind of Intel's, fall back to the pack, right? I mean, I think, the reality is we're probably in year 10 to 15 of a 3 to 4 decade transition away from x86 as the dominant architecture. ARM obviously was there on the embedded side, but really kind of took the momentum from Intel and mobile. We've chipped away at Intel a little bit on the PC side with what Apple and Qualcomm and the AI PC have done, and x86 is the dominant architecture and data center for kind of all of history up until probably the last 5 to 10 years, with really the momentum coming in the last 5 and seemingly going forward. So that's probably the bigger trend here is, we've kind of moved from an Intel world to an ARM world.
When they write the history books on this, Intel's miss on mobile in general is probably, I'm not going to say it's fatal, but it was fateful in terms of allowing a lot of people to come in and compete there. But look, hey,
I got $10 that says that there's going to be an AI agent for converting x86 workloads to ARM before the end of the year. So it might not be 2 decades, Dan.
If there isn't already.
if there isn't already.
Pretty compelling stories there on AWS with customers making that exact
Yep.
transition.
Hey, speaking of AWS, they're kind of groovy getting their vibe on. We're going to talk about that next. You're watching Tech Strong Gang.